Hello everyone. In this video we're going to be solving an exponential equation, a fun one. So we have this exponential power tower, 2 to the power x to the power x to the power x to the power dot dot dot, so on and so forth. All these are x's after the 2, and that is equal to square root of 2. We're going to find the value of x from here. Now, we're going to be doing a lot of different things. I'm going to show you a graph at the end, and we're also going to be looking at some, convergence, interesting stuff like calculus, so on and so forth. Okay, let's get started. So now, I want to do the following. First of all, 2 to the power something equals square root of 2. So can I write the square root of 2 as 2 to the power 1/2? And that tells me right away, since the bases are the same, that this whole expression is equivalent to 1/2. But what is that expression? That is the critical part. So we have x to the power x to the power x to the power dot 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 equals 1/2. Can we solve this equation? And the answer is yes. How? So we're going to look at this expression from different perspectives. From a functional perspective, you can also look at it from a limit perspective. You can define a sequence. You can say, hey, x sub 1 is this, and then x sub n is defined as x to the power, x sub n minus 1, and so on and so forth. Anyways, there are so many ways. We're just going to keep it light. So notice that this expression contains itself infinitely many times. So if you look at the exponent, the whole thing as an exponent, it's the same thing as the original, because it's, look at it, x to the power x just goes on forever. So if this original expression is equal to 1/2, then this must also equal 1/2. This simplifies the problem a great deal. Of course, that's not the end of the story, but at least it gives us a clue. So we get x to the power 1/2 equals 1/2, which is kind of interesting. Right? It's kind of like x to the power y equals y. Anyways, and we'll talk about that later. So from here, I can do the following. X to the power 1/2 means square root of x, right? For the most part. And from here, we can square both sides and we'll get the x value. X equals 1/4. Great. Okay. Let's see if this is acceptable. Now, or when is this value acceptable? So we're going to look at it from a functional perspective. Suppose, and forget about all the x's and other variables. Suppose we have y to the power y dot 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 is equal to a certain x value. Then from here, as you know, we've done this before, right? Just now. This is the same thing as x. So we get y to the power x equals x. And then since x does not equal 0, because that would kind of be meaningless, right? We can raise both sides to the power of 1 over x. So y would be x to the power 1 over x. Yes, this is the function I was looking for. So this is a really nice function. I'll show you the graph of it at the end. But let's go ahead and do a little bit of calculus on this. And don't get scared when I say calculus, because calculus is actually easy. At least the rules, like you differentiate. There are certain rules which you follow to differentiate. Okay? So that's what we're going to do. We're going to differentiate this function. But before that, let's go ahead and bring down the 1 over x. So we're going to ln both sides first. Let's go ahead and do it. ln y equals ln x to the power 1 over x. And then if you bring down the 1 over x, you get ln y equals 1 over x ln x, or you can write ln y equals ln x over x, which is cool. Now let's go ahead and differentiate both sides. When we differentiate a function like ln y, and y is a function of x, right, we have to use chain rule. So the chain rule says, just differentiate whatever method you use, and then multiply by the derivative of the inside. So it's going to be like y prime over y. That's the rule. And on the right hand side, we have the derivative of a quotient, right? The derivative of ln x multiplied by x minus the derivative of x times ln x divided by x squared. And the x's cancel out, and y is the original function right here. We're going to replace that and cross multiply. So it's going to look like this. X to the power 1 over x multiplied by 1 minus ln x over x squared. Awesome. Now what am I going to do with this? I want to find the critical points. Does this function, the graph of the function, have any horizontal tangents? In other words, the derivative changes from positive to negative or negative to positive. Set it equal to 0, and from here x to the power 1 over x can never be 0 right? Even at 0, because at 0 actually it kind of goes crazy. Anyways, 1 minus ln x can be 0, right? And from here we get ln x equals 1, which implies x equals e. Euler's number, that famous 2.7 something, right? Great. So what am I going to do with this? I'll make a graph, because graphs are fun. Not like a graph of a function, but actually not a graph. Why did I call it? I don't know. It's we'll make a table. Okay, but no. First of all, notice that if x is greater than e, then 1 minus ln x is going to be less than 0, because it's going to be greater than 1. Make sense? So that's going to make the derivative negative, because that's the only thing that changes. These are always non-negative, or positive, I should say, because x squared is at the bottom, so x cannot be 0 anyways. So the only thing that changes is by this one. So what do? From here, we can make a table. Let's go ahead and make a table. And on our table, we're going to have 3 rows, kind of. This is x, this is y prime row, and this is the y row. And here I'm going to place my critical value, which is x equals e, because this is the x row, right? So I'm gonna, this is going to be e, and I'm gonna put a 0 there, which means y prime is 0 at x equals e. Make sense? Okay. Now notice that we found out if x is greater than e, then derivative is negative. So our derivative is gonna be negative here and positive here. It changes, of course, at e, right? You know that. Now this is cool, because first derivative tells us whether the function is increasing or decreasing on an interval. Our function is increasing first and then decreasing. Great. That means it's going to have a max at x equals e. But x equals e implies that y is e to the power 1 over e. So this is the y value. And guess what? This is the maximum y value you can get. So in other words, y values cannot exceed e to the power 1 over e, which is approximately 1.44. Okay, great. So for example, if you have, and remember our original expression was like y to the power y to the power dot, and it's equal to x, and we don't want y to exceed e to the power 1 over e. So for example, what happens if y is equal to 2? 2 to the power 2 to the power 2 dot. 2 is obviously greater than 1.44. This is not going to converge, because it is going to exceed the allowable maximum value. Make sense? Okay. But if you have square root of 2 to the power square root of 2 and then square root of, and I believe I made a video, I'll share this right here if I did. And this converges because square root of 2 is less than 1.44. Or, to be more exact, this number is less than e to the power 1 over e. Therefore, this is going to converge. Great. So, what does this tell us? This tells us that the answer is, what was the answer? What was I looking for? Okay, x. Great. The answer is 1/4. Okay, so let's go ahead and take a look at the graph now, and we'll finish up. But before that, let's go ahead and look at a couple of values. Remember, we said that x equals 1/4 is the answer, the only answer. And if you look at some, towers, 1/4 to the 1/4 gives you about 0.7. Okay, if you include more 1/4, then the value gets smaller dramatically, 0.37. So we expect to get square root of 2, right, at the end. No, actually not really, 1/2. Okay, so all of these are going to give us 1/2, so 0.5-ish. Yay, we got pretty close. Okay, up and down, maybe it oscillates, but notice that the values are getting closer to 1/2. That's not a proof. I'm just showing you a couple of examples. And here's the graph that I want you to take a look at. The graph of y equals x to the power 1 over x. Notice that we have a maximum at this point, and the allowable maximum value for the y is as such. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.